Good morning, everybody. We'll get started in the interest of time to keep the ball rolling. Am I echoing? A little bit. Turn down the volume a bit. All right, we're going to get started. So I'm going to be talking about SerDes camera, LiDAR, sensor logging, and gatewaying of signals, trying to transfer information between networks. So let's get ready to drink from a fire hose. So today there's obviously no shortage of challenges.
Hard to hear.
Hard to hear?
Yeah. Move your mic closer.
Is that better?
Try to talk
I will talk louder for once. Usually at home they tell me to not talk so loud, so I'll raise my voice. Let me know in the back if you guys can hear me. So no shortage of challenges, obviously, we've talked about all morning. What I'm going to try to show you is the capabilities to simulate, capture, analyze, and gateway signals across the 7 different networks that are in the RadMars product that we have outside. And I can show you guys a live demo if you'd like. So we'll go through and show you a video recording of this live in just a little bit. So some of the underlining functions that will support this is having the ability to have a high bandwidth and high capacity data logging and storage system. And also the ability to forward Ethernet traffic and CAN traffic. And also the ability to time align that traffic. So let's get started. So in the vehicle, there's many different data generators right now. So we've got cameras, LiDARs, radars, 10 gig base T backbone networks now starting to come about. Driver behavior systems. So a lot of times federally mandated, you need to make sure that you have a driver monitoring system in place to know what the driver was doing if there was an event that occurred while you were driving autonomously. And we do see a lot of now thermal imaging systems coming out, trying to increase the range that the driver or the user or the machine can actually see at nighttime. So I found this very interesting because a lot of times we always make a comparison between the human driver versus the machine driver. And that comparison typically uses things like our eyes, the thing that we sense the world with. And in this study, they showed that what is the resolution of the human eye? I'm just setting a timer so I know how far I go. The resolution of the human eye, they've calculated to be around 576 megapixels. But what does that really mean? That is the movement of the eye around its eye socket. So if you really take a single snapshot of the eye, you're around the 5 to 15 megapixels as a resolution for that single snapshot when you blink your eye. So I found that very interesting. So we're approaching what has been put together in this scientific study. We have 12 megapixel cameras on consumer products like this, and we've got 8 megapixel cameras coming out in the SerDes technologies as well right now. So we talked a little bit about the design challenges. So what is new today is going to be obsolete tomorrow. It's literally developing and changing that fast. Whether it's platforms, subsystems, anything in this room right now was not here when the original CAN bus was designed and out there in every single vehicle right now. There's not a single thing in this room that was here at that same time. EV propulsion, we're seeing more and more expanding into series production, mass production right now. So the need for flexible test equipment has never been greater, of course. The ability to simulate, capture, and analyze, like we've seen in the earlier presentation, bringing to virtual testing sooner in the development cycle. A lot of the OEMs I hear, there's a vision of having 0 prototype vehicles by 2025, 26. We've been saying this for the last 2 decades, guys, but now with the chip and part shortage, it has the ammunition and the legs to grow to get more into the virtual world. And we're expanding in those areas as well. So coupled with these challenges comes the larger and larger data sets that we see out there. And even just to configure a vehicle, if you're working with any Ethernet technologies like the ARXML files, they're approaching and exceeding and breaking the barrier, the 2 gigabyte size limits, right? Just to configure all the different topologies in the vehicle. So it becomes very interesting when it comes to the challenges. So everybody has a missing ECU in their architecture right now. I don't care which OEM you're at. If you don't, I'd love to know because I need to buy a new vehicle. So, but at the end of the day, if you're missing some ECUs, you can still continue your testing by being able to simulate the ECU's traffic. This is not new. This has been around for many years. It's been called rest bus simulation, residual bus simulation. At the end of the day, we can help you bridge that gap from having a missing ECU to getting the real ECU in time. Doing that, some of the things that you would are able to perform is being able to develop or import an ECU simulation and run that in real time on our hardware. This is a little advantage that I think we take it for granted working for the company for many years, is having a real-time simulation, or maybe I could better say a cycle accurate simulation in the milliseconds range, right? So we've got a round robin millisecond scheduler that performs, once we compile our function blocks, that's how our function blocks run, is in this round robin scheduler. To simply think about the simulation capabilities. You have the ability to generate the startup messages from an ECU, broadcast messages, obviously being able to read in the ARXML files or the DBC files, of course. This has been around for many years now in Vehicle Spy. But now being able to create automatic response traffic, those are some new things that we've had in there for now a few years now. But now the gatewaying of signals. So now if you have a missing ECU and your ECU is actually a gateway ECU, you could use the simulations to now transmit the data across different networks with, say, one of our hardware products. This next one, number 4, maybe to a question earlier, is how would you manipulate, say, a man in the middle for CAN? Is you would do a physical CAN isolation. So you would have 2 CAN networks. You would physically isolate one with our hardware, read that information, do the software gateway using our gateway builder, and transmit it across the second network. This physical isolation allows you to check different fault code diagnostics. So if you want to say you have a fault code diagnostic that's going to trigger after 100 milliseconds, well, with this isolation of the 2 CAN buses, you can increase the latency of that message to 200 milliseconds, 250 milliseconds from one network to another to be able to check that fault code diagnostics. You could do that on a bench or even in a vehicle. So just trying to simply explain some of the features that you can do when you don't have your real ECUs in the mix or in the loop. Of course, you can filter unwanted traffic, and unique capabilities and features is using our hardware to simulate some of this traffic. It has the capabilities to simulate the ECU traffic, but also act like the vehicle network adapter. So being able to see all the other ECU's traffic and see how it reacts to the simulated ECU's traffic. So on the Rad Mars product, we actually have 7 different interfaces, and they're all listed right here. Everything from 10 gig Ethernet, a couple of 1 gig Ethernet -Ts, a couple of T1 ports, 100 base, and the 2 cameras in and 2 cameras out SerDes, along with 8 CANs, CAN-FDs, 1 LIN, and then a discrete digital output that can be used for Ethernet activation for, say, DOIP. And we also have a couple of FlexRay read-only channels, received-only channels. So now, when you're capturing your data, we've got a really comprehensive GUI called the VehicleScape DAC. And within there, you can capture messages, buses, histograms. What's very interesting is that item number 2 is multiple concurrent captures. And a lot of times people want to capture multiple events. If my EV charger arbitrarily dropped a bit or turned on when it shouldn't have, I want to be able to trigger on that event, and I want to know what the data was 10 seconds pre, 10 seconds post. So you can do those pre-post conditions and do concurrent captures. You can now, in number 3 up there, you can select different networks and filter on different networks. This is a new feature actually we've added, I believe, in 3 or 4 revisions ago, maybe in last year, I should say. Manual mic 2 button presses. I was just chatting with a customer outside about our mic 2, and it's very useful because you can do an audio annotation on the mic and actually trigger and see the trigger stored in the data log of your capture. Power management, of course. Who wants to wake up to a dead battery in their vehicle? No, nobody wants to wake up. I don't want to wake up to a dead battery. So we actually have power management built in right through the scripting to help you cut out that log or voltage with a specific voltage or a specific time. Some encryption settings that we have on the hard disk came from some other customer requirements. And then all of this can be generated in real time or pushed down to the hardware and run in real time. So we talked a little bit about this in one of the earlier presentations about synchronizing multiple data loggers. So now I get the question, okay, now I have 4 cameras. I have 8 cameras in the vehicle. You can only read 2 cameras in, 2 cameras out. What do I do? Well, we can synchronize multiple data loggers to have the same global hardware timestamp. It's a mouthful, but it gives you a lot of features and functionalities. That way, when you're looking at different anomalies, when all of your data loggers are logged and synchronized to one time base, you can now do some timing analysis. And the next slide, I'll show you a little bit about that. In the next slide, I actually combined multiple VSB files together using our file utilities tool. And I was able to see a less than 2 microsecond accuracy across the devices. On some select devices, like we've seen earlier, we're actually implementing GPTP, the automotive profile as well. So over here is a log of a synchronization of the global hardware timestamp. And you see the numbers 1, 2, 3, 4. These are the 4 separate individual networks. And I applied the networks across different network names. So you'll see HSCAN, the VNet A, VNet B, and also HSCAN 2. So within those 1, 2, 3, 4, to the right of it is the timestamps, and to the right of that is an expanded area of those timestamps showing that accuracy. And you can see all those numbers are fairly good. I didn't zoom in on it, but a little bit lower down, you see a couple of microseconds differences. I think I've calculated right around a 1.7 microseconds, but I safely say 2 microseconds to get me out of any trouble. So this was the capabilities of our Intrepid Control time sync. Now, when we have larger and larger data sets, we've got a software program called Intrepid Data Spy. So Vehicle Spy is great for working and analyzing data sets, but when you start bringing in images into the data sets, obviously the data sets start to expand over 2, 3, 4, 10 gig. With the Data Spy software, you're able to time align discrete CAN events to different video images. At the bottom, we've got a couple of YouTube videos. They're an hour long. If you're interested in that, please let me know. We can walk through kind of a little bit more of a discussion. This one was very, this slide is actually very detailed because in the first entry, what we're actually doing is we're analyzing using a simple YOLO, you only look once algorithm. And we ran that image processing on an x86 processor. And people said it couldn't be done. Everybody always wants to use a GPU. But in this aspect, we were processing JPEG images. So you can use an x86 processor, and it was decent at a JPEG image. Of course, if you started using raw images, it would really start to bog down that processor. But we wanted to see as a proof of concept, we've got a lot of customers with tons of data out there, And they can use this now, this process to be able to sift through the data and find different visual anomalies and to time correlate that to what the discrete events are doing in CAN. So this now is showing our gateway builder and the capabilities to be able to record and forward the data. And I just show these 3 steps, right? So you've got the input side, you've got the output side, and you've got a button in the middle that pretty much says gateway the entire network. You really can't get much easier than that. This is exactly what I did in the demonstration outside, where I'm recording the LiDAR data using this exact gateway builder setup, forwarding that data out of another Ethernet port to the PC to be able to visualize in real time while we're recording the data and synchronizing it to CAN and other Ethernets. This is actually that LiDAR visualization that I'm showing and talking about. So it can record the Ethernet, it passes through the Ethernet, records the SerDes data, and we're also passing through the SerDes data. We're doing an I2C sniffer and spy, and we're also monitoring the SerDes packet information. And in the next presentation I have in the afternoon, we'll talk about that packet information monitoring and some of the kind of neat little pixel tricks that we were doing. So within the vehicle spy function blocks, mixing that with what's called application signals and our core mini millisecond round robin scheduler scripting engine, you can now copy data from one network to another network seamlessly, and being able to marry different networks together. So give a simple example. When my camera data pops up and is configured, I can transmit the frames per second from our hardware status message into an application signal, and out of the application signal, push that into a CAN message and to report that to maybe a supervisory controller or maybe some other tool or some other test equipment that you would have. So this gives you a little bit of an example of gatewaying the signals between the networks. I forgot I did some animation in this. So this is very critical. I actually just added this slide this morning because a lot of times customers will go out and record data and then they get back and their data is missing. And nobody wants to admit it. Nobody wants to sign up for that. Yep, I just spent a week in cold weather and I just lost 12 terabytes of data. So having a state of health, of understanding when you're in this development vehicle, did all of the ECUs turn on? Am I driving around with half my ECUs on and half my ECUs off? It's happened. I've been in vehicles. So knowing how many messages per second is good before you take off is very critical, knowing that state of health. So we have a product called VividCAN. It's a very simple human-machine interface, touch screen. A lot of customers like it when prior to isolation, OEMs kept on driving. They needed to collect millions of miles, durability. This device was able to survive the chemical spray of whatever disinfectant that they would put in the vehicles. I actually got a couple of emails from customers about that. I was really impressed. That chemical spray does deteriorate the film on these touch screens. So good luck if you're using a tablet out there in a real vehicle. So with the VividCAN device, we can look at how much storage is left on the device. You can physically look at the device and we've got some status LEDs, but you can now see how many megabytes or terabytes of storage that are left. You can start and stop manual triggers right from a user display. So if something happened, you can start a trigger, drive around, and you can also stop that trigger. This is where that multiple collection starts to come into play. And you're also able to clear some statistics and whatnot. So in number 5, what we're looking at is all of the CAN messages. How many messages per second do you have going on in your vehicle? Say you've got 8 CAN messages, 8 CAN buses. You could have 10, 20, 30,000 messages a second. You want to be able to see that number and record that number and tell your driver, hey, Mr. Test Driver, if you don't see 10,000 messages right here, you better stop, turn the vehicle off, turn it back on. Oh, there's my 10,000 messages. Okay, now you can continue. Because a lot of times, if you don't have the entire gateway or ring built in a vehicle, you might not have all of the ECUs operating and functioning all together. There's also detailed views that I've created for customers looking at the different error rates, message cycle rates, and the Ethernet message utilization and whatnot. So looking at the bus load and also the messages per second, even on an Ethernet bus. Another example is you have two LiDARs, mixing them into one Ethernet channel. You're expecting 16,000 frames a second or 16,000 frames a second. And you're only seeing 8,000 frames a second. Well, you know, one of your LiDARs didn't turn on or didn't configure properly. So it's just a tool to help the test drivers ensure that you're capturing data properly. So this is a video that I captured of the presentation outside, demonstration outside, showing some of the capabilities. Let's see if we can. This is our LiDAR demonstration. Right now, I'm showing you an overview of the data recorded. We have a developed LiDAR that Ethernet information is being fed into our 10-gig port. We're using a Visualization software to forward that traffic out to Ethernet 1 port. That is going to Ethernet USB converter, and I have a small USB converter hub right here. So let me stop it right there because there's a lot of things going on. You can see in the demonstration outside, but basically what I've done is to be able to do all of this using one Ethernet port. I've decimated some of the data coming back to the PC. That is the only way you're able to log all this information. If you see what I'm working with, and I can show you out there in the demonstration, we have all of this information going into a single USB hub going back to the PC. And what I'm doing is I've decimated the real-time streaming protocol to Vehicle Spy. If you see on the right-hand side of the image, that's the Vehicle Spy software. On the left-hand side is the deserializer imager out data. And that is not being decimated. The only decimation is occurring is on the Vehicle Spy side. And that way we're not loading down the PC. In my next presentation, I show the ability for RadMars to load down the PC to the point of complete, unusability. And then I would have to kill the network stream coming from the hardware. So again, just showing you the capabilities of being able to mix the data, but also using commercial grade laptops and whatnot to be able to visualize and see what's going on with the data. So I'll save everybody the agony, but it's essentially at the end of the day, you can actually see it live outside. So I'm reporting the information from the SerDes as well in Vehicle Spy. So if you've got questions, please come out to the demo and I'll give you a little bit more on that. So now, this is now an extraction and export and the capabilities to review the data buffer. And I'll let this one play. This was a little bit more interesting. So what I can do directly is I'm recording the LiDAR data, replaying it in Vehicle Spy, saving a PCAP file of that recorded Ethernet data, and then replaying that in the VelaView software. So that's what I'll be showing right here. This is a little bit longer of a video.
In this video over at Mars, we're going to start to extract the data. So I open up the data tab and I hit refresh. That will now start talking to the hard drive, and that can suspend the operation for me to allow the device to give us a peak performance. Right now it's showing we've got about 11.5% full, and over here is a tree view of the triggered collection. So we'll grab the last entry. I think this would be the last entry. So that is our trigger recording. We'll start to extract that data now. After we extract the data, we'll be able to export the data in several different formats. We allow a ASCII, ASC, CSV, MP4, and back file format. At the bottom of the Digital Spy 3D software extraction window, you can see the progress bar going right now.
So-
We're extracting data.
It's difficult to see, but that little bar down at the green bar down at the bottom. And I was just about to stop the video, but it actually extracted completely and finished up. So I just and kept the video going. But now we're extracting the data, the binary information. We're extracting the binary information called VSA. And now in the newer releases of Vehicle Spy on some hardware, you can actually extract that binary data and use the power of your PC to export it into a.
So that will, not going to save my changes. We'll save that.
Yeah, so I'll let this play, but at the end of the day, we're reviewing the extraction.
Bring up a prompt now and ask you, do you want to load this into a new platform or an existing platform? I'm going to just select new platform. And I'm going to bring down the video tool and I'm going to put that video tool on the right side. And if you'll notice in the video tool, it says review camera. So right now, when I go to do my simulation, browse, so the simulation opens up over here. Grab this path, and I'll say run simulation browse, and paste that path in there. And you can get to that folder and get to that collection. So now when we go and simulate, we'll hit the maintain aspect ratio. So now you can see myself when I was wiggling my fingers and I press the mic button, you can see the mic LED recording right there. Over here, what we have scrolling is we have all of that internet traffic scrolling along with any can traffic. Also, what we would see is the SerDes status information as well right there. So that is the ability to extract data and then review data offline and find your anomaly. So right now, if you find an anomaly, you can look at the time of where that anomaly is, and now see a feedback of this data. But here we can say same plus graphic 11111 at the end of it. And what do I want to say to PCAP file? And I believe this will go into the data folder, so we can open that up right now. And I will hit save. So now we just saved that traffic as a PCAP. I will right click and go to grab this file for right now. And I'm going to develop new software and to disconnect.
Of course. Come on.
We will load this file. So with the sensor stream file, or capture file, with the capture file, we'll paste that directory right there and we'll load this 111 traffic. That is set. We'll go for a VLP16 configuration. So now I've loaded that data and we can actually play the data. So now we're replaying the data and you can see with my hands, when I raise my hands, what was going on. So
It's hard to see in the video, but I was doing this with my hands.
to
So
allow customers to go back when they find an anomaly through the video and internet data, they can come back and actually visually see what's going on with their device.
if anybody wants to see this, I can show that in the back. because I know it's a little bit difficult to see in here. But it's really nice to be able to just record the data simply through a few button clicks, be able to go load that LiDAR data, and then go into that global timestamp and be able to visualize what the LiDAR was seeing or not seeing in that regard. So I'm right on time. Thank you, guys. Thank you for your attention today.